What's up guys, welcome back. We are standing in front of the old silver VESS again, not the supercharged one we built. This is another one. For those who don't remember, this was here for a flex fuel tune late last year, and the whole theme of that whole video was pretty much about how much power this thing doesn't make. So for anyone who missed the last video, we did a bit of a flex fuel tune on this thing last time it was here. A basic rundown is we've got a rebuilt stock bottom end L98. It's got CNC ported heads on it, so CNC ported rectangle port heads. Fast LXXR 102 intake manifold. We've got some big pipes, OTR, you know, all of the ingredients to make a big chunk of power. Not only that, but it runs on E85, and essentially it doesn't make very much power for how much work's gone into it. You know, you'd think something with that much work running on E85, you should be able to make a fair bit of pepper out of it, but this thing just didn't make the power. So through that whole tune and through that video, what we were sort of predicting is the fact that the cam in this thing is just too small. It's not the right cam for the setup. You know, we've got heads that want to scream, they really want to flow, and we've got a cam that's just not really enough lift. The cam's just not very much lift. It's a really tight lobe separation angle. It's just the wrong cam for the setup. Not only that, but if the heads have been CNC ported, we do predict that not enough has been skimmed back off them to get some compression back into this thing. Being E85, you really need compression to take advantages of what E85 has to offer on something that's aspirated, particularly in LS. So when you get your head CNC ported and they CNC the chambers, they actually take out quite a bit of material, which actually drops the compression quite a bit. So it's very important to skim quite a bit off the heads to try and get some static compression back into the combo, so that, you know, with your cam selection, you get some dynamic compression back into the combo. So this cam, between being really low lift and really tight lobe separation angle, we're actually dropping that dynamic compression a heap. And if these heads haven't been skimmed and the static compression is already really low, well then there's just not enough compression in this engine to actually take advantage of the E85. And obviously this cam just doesn't want to do what we want it to do. So it's back here today. We're going to pull these heads off. We're actually going to pull the motor out, pull these heads off. We've got a new cam to go on this thing. We're going to try and sort these heads out and get it back together and actually see what this thing can do, this setup. Hopefully with a bit more static compression, a bit more dynamic compression, and hopefully a little bit better suited cam. So let's see what this thing can actually pull out of the bag. So to start with, we started on removing the engine from the car. Most of what we're doing to this engine could have been done with the engine in the car. The only reason we really decided to go to the effort of actually removing the engine is that our fly cutter heads are starting to get pretty sad. They're not as sharp as they once were, and the company that we get them from the USA actually couldn't manage to find someone who would ship a new set over to us in time to do this job. So considering that we had to use our old fly cutters, which were a little bit blunter than we'd like, we decided to actually pull this out of the car. It was going to be a lot easier to do than trying to mess around trying to do this with the engine still in the car. It's also a little bit safer, being able to ensure that no swarf gets anywhere that it shouldn't. So we figured by the time we messed around doing that, we may as well just pull the engine from the car. So out it comes, and so starts the beginning of the pull down. The harmonic balancer bolt was incredibly tight, and so was the harmonic balancer. It was actually so tight on the crank it wasn't funny, but we managed to get it off. Whoever last put this all together really gooped up all of these gaskets. Everything's completely gooped up in silicon, so it must have been leaking from a few areas. We're probably going to have to replace quite a few of these gaskets as it goes back together, which we hadn't accounted for. But that's what happens. So apart it comes, we just checked a few little things as we were pulling it apart. We checked the lifter preload and a few other little bits and bobs. Off came the heads. Sorry guys, the camera went flat at this point. And so we began cleaning up the heads in order to CC them and check the chamber size. Righto guys, so there you go, we've got this thing apart, we've got the heads off. We CC'd a head and it's come up at 72 cc's. Now these things standard should be around 68. So the CNCing of the chamber has taken out 4 cc's worth of material, and then nothing's been taken off the deck to try and bring this compression back in. So we did a quick piston to deck height check, and Rex has run the calculations based on what the piston to deck height is and what these heads CC'd at. This thing would have been running around 10.1 to 1 static compression. And then I don't remember the exact specs on the cam that was in this thing, but it's really low lift, quite big duration, and it was only on like a 108 LSA. So as you can imagine, with that sort of lobe separation with a cam with fairly big duration, your dynamic compression's already dropping quite a bit, and if you're only starting at a 10.1 to 1 static, it's just not enough compression for this thing to make any power, and that's where it's been leaving so much on the table. So we've worked out by taking around 50 thou off the heads, should be able to cut out about 8 cc's, so we should be able to bring that back to around 64, which would be obviously ideal. That's about as much as we're happy to take off standard heads. It's really, any more than that and you start to run into issues with your manifold fitment and everything, being that these are, you know, a V configuration, and the more you take off the head, the more it's coming down closer together, the harder it starts to get to fit the manifolds. As it is, we're going to have to actually get the valley plate milled a little bit to try and drop the valley plate bolt heads, maybe even go to some button heads just to get the intake manifold to clear the actual valley plate bolts when it all goes back together. So this is really the restriction with doing this sort of thing on your stock bottom end LS. With stock pistons, there is only so much compression you can get into these things, and that's really the limitation of a stock bottom end build. So there's not much else you can do to get this compression in there. So once you can keep going bigger cam as much as you want and different fuels like E85 and all that, but you're really going to hit a wall as far as what you can actually do as far as power. And that is why we tell people, you know, 500 wheel horsepower on a stock bottom end 6 litre, it is a big task. It's not impossible by any means, it is definitely possible, but it is a big task without going to different pistons and actually getting some decent compression back in this thing. So, so based on being able to get around 8 cc's back in the heads, and then we've worked out that our valve release from our fly cutting to suit this new cam we'll call it 2 cc's to be generous. So it will be about a 6 cc change. Based on that difference, Rex has worked out the new compression is going to be closer to 11 to 1 comp. So, you know, 11 to 1 comp is far more favorable than closer to 10 to 1, particularly with this new cam having a lot more lift. We're going to be taking a lot more advantage of these really nice big ports in these heads and trying to get this, you know, this engine flowing some air and actually making some power. So we'll get these heads to the machine shop now, try and get this back together tomorrow is pretty much the idea, but pick it up then. For anyone wondering what I'm bagging on about when I'm talking about dynamic compression versus static compression, maybe consider becoming a member. There will be a members only exclusive informative video released about static versus dynamic compression very soon. So the cam that we picked to go back into this combo is actually a complete off-the-shelf grind from Crow cams. It's not a cam that we've often used or normally would use because it does require fly cutting even on very basic setups, which we usually try and avoid. But seeing as this combo already had the CNC chambers and he wants to run it on E85, we had to shave so much off the heads that pretty much no matter which cam we chose, we're going to have to do some fly cutting. So seeing as though we had to do some fly cutting anyway, and we've got already the CNC ported heads and a decent converter, we thought why not just go for a big boy. The owner wants it lumpy, he wants it angry, he wants it powerful, so we chose a cam to suit. So the specs on the 1289, we've got a 238 duration on the intake, a 254 on the exhaust, so quite big duration. We've got 614 lift on both the intake and exhaust, so quite a bit of lift, especially considering the cam that's coming out of this thing was something ridiculous like 560 lift or something, just nowhere near enough to really take advantage of these really high flowing heads. So some nice big lift on this cam to really get these heads moving some air. And we've got a 113 lobe separation angle, so if we can get the static compression up to what we think we can based on what we want to do to these heads, coupled with this generous valve duration and valve lift to get this thing screaming, we should have ourselves a really well matched combo, and with this 3000 stall converter it should still be quite streetable and happy to drive. So I'm going to film this little segment outside of the engine room because I'm getting these annoying green lines from the fluoros in there which I can't figure out on the camera, so I'm going to try and do most of my filming in the engine room from now on with the GoPro because I don't think it gets those lines. Anyway, regardless of that, just wanted to point out a few things. Now, whenever we film videos of us building LSs, I sound like a broken record, but I always crack on about how important it is to shim the oil pump. It's so important to shim the oil pump because they're not doweled. There's nothing to center them, there's nothing to locate them. You have to locate them centrally on the crank. Now, when we pulled this oil pump off, this is a Mellings pump, the bolts that actually bolt the pump to the block had been Loctited, but the bolts in the cover had nothing on them, which would lead us to believe that it was probably installed with the cover on. The cover had never been off. And this is what you can see with the pump. Hopefully I can get the camera to focus well on this. So if you see the top there, well, it's actually the bottom of the pump, but at the top of the camera there, you can see the wear marks on that side. Now, it is our understanding that this engine has not done a lot of work since it was built. So, you know, that's quite a bit of wear on that side. And then you move the pump around and you can see the rest of the housing. There's no wear marks, nothing. So this is pretty typical of, obviously, most of the time you put an LS oil pump on, the engine's upside down. So as you can imagine, the pump probably went on, the weight of the pump was holding it down on the crank like so. and then it was just bolted in onto the block without the actual oil pump housing being centered about the crank. So, you know, we often hear, you can actually see even on the inside on the collar there, the wear there. So you can see it was really not located properly at all. And you always hear of people ragging on about LS pumps being terrible, about LS pumps failing. There is literally no reason that an LS pump should fail, provided it's been installed correctly. Obviously, this is a Mellington pump. It's a bit of a moot point with this particular pump, but I do see a lot of the time people giving stock pumps a hard time. We're a big fan of stock pumps, particularly on engines that are doing fairly high RPM. You don't want high flow. You know, things like this in an auto street car, things like this are fine. That's fine. But you know, if you're building a drift engine, high RPM all the time, you don't really want higher flow pump or a high volume pump. All you're going to end up doing is draining the sump faster, and it's you're just going to starve it full of oil faster. The standard pumps are plenty enough flow for as long as you're doing RPM, and as long as they're centered about the crank, you're not going to have them seize up or gal up or create problems. But if you install them not centered and they're wearing on one side, they're not getting that nice film of oil on one side, that's when you're going to start hearing about these pumps seizing up and causing issues. So just thought I'd point that out. This is why I'm always ragging on so hard about how important it is to shim your LS pump. So this engine had an issue with the front main leak, and you can see on the front main cover as well, the crank was also wearing furthermore on one side of the main seal. You can see it in the wear marks on the main seal. So we're also led to believe that it was probably put on and then tightened down onto the sump instead of being put on and centralized and tightened to the block first. So just little attention to detail, things like that, which are going to go a long way as far as the longevity of your engine if you're building an engine obviously yourself. So just wanted to point that out. We'll get on to swapping this stuff over. All right, so we've come across a few other issues. We've gotten a little bit further into this thing. Firstly, you can see the cam retainer plate hasn't been chamfered to accept the Torrington bearing on the cam gear. This is another thing I often rag on about. It's not a super important thing to do. Like, this will sort of just wear itself around eventually, but obviously it's not what you want in an engine, to be wearing hard metal parts. So we always talk about just chamfering that inside, just the lip on it, just to get a little bit of clearance for the inside of the cam gear, so that the Torrington bearing actually runs on the cam plate and does its job properly. But the big issue we've come across is that these countersunk bolts have been heavily butchered, and this one's so rounded that we are having a lot of trouble trying to get anything in there to actually turn the bolt. So yeah, this is not a lot of fun to be trying to deal with. So anyway, we'll see what we can sort out. Rex is super stoked about this sort of thing. Righto guys, so nothing that we've tried with tool-wise is going to get this rounded bolt head out, so we're resorting to the old welder trick. We'll weld a nut to the bolt head, hopefully get it out that way. They should not be torqued too high. These bolts don't have a very high torque rating where they are, so fingers crossed a bit of a weld and a nut should get it out fairly easy. All right guys, so luckily the weld and the nut trick worked. We managed to get all of the bolts out, which is awesome. That's a bit of stress relief now. So we've got some new cam retainer plate bolts, and we're going to actually just chuck a new plate on it as well. Just the bit of heat that went into it, because it's an alloy block, which would have taken a lot of heat out of the actual plate, but we'd rather just sort of save this plate for use for one of our own engines and put a new one on this one, just for some peace of mind. And then yeah, we've got some new bolts there to replace those. So you can see what I was talking about with this plate. So these are the sorts of things I rag on about all the time, guys, but it's not often that I get to show you like an illustrative example of what happens when you don't do it. So you can see the inner of the hole in that cam plate has just sort of been ground away. Now what's grinding away that is the actual inside of the cam gear. So these cam gears have what we call a Torrington thrust bearing. So that's an actual bearing that rolls around and runs. And I don't know if you'll be able to see it on the camera, but the inside of that's not moving there, that's actually part of the cam gear, and it actually protrudes through the Torrington bearing a little bit, sort of just maybe a mil, half a mil-ish. It's not much, but it is enough that obviously once that's mated to that cam retainer plate, don't know if you'll be able to see on the inside there, it is then the actual protruding part of the cam gear that's just grinding away at the cam plate. So that's what we always do when we chamfer the inside of these cam retainer plates, is just give that a little bit of clearance for that cam gear to sit in and roll and be free. And that way the Torrington's actually mating to the cam retainer plate and doing its job and running the way it should be. So that's what we're doing there. So we'll get the new one out and grind our chamfer into it and sort this out. Righto guys, so we've got our heads back. Leith there at Kingito, machined them literally overnight. We literally got them to him yesterday. He had them back to us this afternoon. So a huge big thank you to Kingito there for literally getting them done overnight. Absolute G's. So big thanks to Leith there. We ended up getting 60 thou taken off them after a bit of talking and doing some calculations and stuff. We thought we'd give 60 thou a try. We also did some careful sort of measurements and looking at the intake manifold as well, and we're pretty confident that at 60 thou this is still going to work fine. So in order to try and get just as much compression into this thing as we possibly can, we just went with 60 thou, and we've CC'd them up, and it is exactly as we predicted at pretty much around 62 cc's, just under 62 cc's, which by our calculations, or our conservative estimate, should bring this thing to that 11.1 to 1 comp, which will be miles ahead of the 10.1 to 1. So that's going to be awesome. So it's now time to get on to our fly cutting. Alright, so actually having the cam out and confirming what it is, we've looked up the specs, and yeah, it's a 227, 241, 561, 545 on a 109. So this cam being on such a tight lobe was just bleeding whatever dynamic compression this thing had, which was very little because of how big the head chambers were. And with that tiny bit of lift, those heads just weren't even sneezing. So, you know, just not the right combo paired together. We reckon this cam's going to do much better for us. Alright guys, so after all the things that we found on this engine along the way, we are super duper glad we did decide at the start that we would just pull it out of the car and not try and do this in the car. Due to all the adversity we've been faced with, this would have had to end up coming out of the car in either case. So it saved us a fair bit of time actually just deciding to pull it out. So with these heads now cleaned up, with all the swarf out of them, cleaned up the faces, it's time to go back on the engine, not for a final install, but just for some measurements. So what you're watching here is the process of us doing some very careful measurements with valve drop, as well as cam timing and valve events. It's very important to do this over a fair bit of the crank angle. As you'll see by the numbers, it's not always top dead center that these valves are closest to the pistons. In fact, that's very rarely the case. So we have a certain amount of clearance that we go for on both the intake and the exhaust. These amounts are different due to the nature of a valve train, and these numbers do change with deflection once you actually have this valve train loaded up with a decent spring. So while the engine's running, these numbers won't be exactly what you're seeing here. However, it does give you a pretty good idea to go off, and this is how we work out exactly how much we need to fly cut out of the piston, as you don't want to be taking any more than you need to. Taking more than you need to not only drops the compression more than you want to, but it also, the more you cut into the piston, the weaker it, in theory, makes the piston. So a lot of very careful measurements during this process. As the old saying goes, measure twice, cut once. So these here are actual fly cutter heads. These are the tools that we use to fly cut pistons. We'll show you how that goes in the coming few segments of the video, but these are the fly cutters. Their heads are getting quite sad on them. They've had a fair bit of use. The last engine that we did with these, we actually ended up having to spend quite a bit of time cleaning up the valve reliefs on the pistons with a die grinder, just because of the way the heads have gone, which is why we decided to pull this out of the car, because we knew we were going to have to clean up these pistons with a die grinder. We did try and get some new cutter heads on the way. We tried to get them in time to do this job. We've had this job booked since well before Christmas, but unfortunately the company that we buy these from the States couldn't find anyone to ship them to us because of COVID. So we couldn't get any new ones. That's why we've ended up going this way. But yeah, we'll show you how we use these. All right guys, so here you're actually watching the fly cutting process. It is a very long process. We use one of our own heads, as the rotation of the cutter head in the valve guide does tend to sort of put some wear on the valve guide. So rather than wear the guides of a customer's head, particularly one that's already got valve stem seals and everything attached, we use one of our own bare heads.
to do this process. There's no way around it. The heads have to go on and off about 1,000,000 times. We can only put one cutter head in one side at a time, as we only have one stem. That was another reason we wanted to buy another set of cutter heads, so that we get a second stem. That way we can at least cut this time down a little bit. But anyway, regardless, that is just what we have to work with. Our intake cutter head at the moment is particularly blunt. It is quite hard to get it to cut. So it's just a slow, boring, old process that just takes a very long time. The customer's head with the 60 thou taken off the deck goes back on to retake all the measurements to ensure adequate clearance. Obviously, this is much better to do in the build process before the final assembly of the bottom end, for obvious reasons, being that you can take all the pistons and crank out and actually clean everything out properly. But we just be as careful as we can. Do this as careful and slowly as we possibly can, ensure everything's clean, ensure no swarf gets anywhere that it shouldn't, and we just very carefully clean everything as best we can before we start putting anything back together. It's a little bit agricultural, but hey, you got to do what you got to do on an engine that's already built. This combo already owes this customer quite a bit of money, so he doesn't have a whole lot of budget to spend for us to try and sort this out, so we're doing it as best we can for as cheap as we can to get the best result that we can, and this is how we're going to do it. So given what we had already seen from this engine, we were half tempted to actually pull some of these springs off and check the installed heights. I may still check the installed heights of the springs we've already removed from this customer's head, but I know exactly what springs these are. These are the exact springs we use on a daily basis. They are the pack springs, dual springs. The VTK LS8 is the part number. I know for a fact, off by heart, the installed height for these valve springs is 1780, or 1 inch and 780 thou. Given that Higgins have done a full CNC job on these heads, it's a pretty safe bet that they have done either a 3-angle or a 5-angle valve job, which in our experience every single time means you have to shim the valve springs to get the correct install heights. Just looking at the valve stem seals and the spring seats, I can't see that these have been shimmed, and given what else we've seen from this combination, I could really probably put money on the fact that they haven't. This cam is fairly aggressive, it is a fair bit of lift, but obviously to remove all these valve stem seals and shim the spring seats so that we have the correct installed heights with all new valve stem seals is quite a bit of labor that wasn't quoted or accounted for, so I'm going to have to call the customer and just confirm with him whether he wants us to go down this road. I would feel a lot more comfortable about the installed heights being correct. Alright guys, and this is what you're left with, the final product, all fly cut, very carefully cleaned up and ready to be reassembled. We checked the installed heights and they did come up as 30 thou too high. We need to shim these springs 30 thou. I did get onto the owner, and sure enough, the consensus is to ensure this thing goes back together properly for one final time. So I've decided to pull these heads apart and shim all of these springs, all the seats, so that it's right. This here is our valley plate, which we just got back from Kingato. Huge thanks to them blokes again, coming through with an overnight setup. So this is milled down 1 mil, and then we're going to be using these mushroom button head M8 bolts to try and get some more manifold clearance for the intake manifold. So time for it to all go back together. We'll ensure we shim this pump as it goes on. We'll also install the front main plate and front main seal centered around the crank so that we don't have any main seal issues. We've also replaced the front main seal. We're putting a brand new one in this time. We decided to also put a timing wedge on this thing when it goes back together, seeing as it didn't have any sort of timing dampener at all when we pulled it apart. This one here is specifically made by our boys at SP Automotive Engineering in Deception Bay, and it is specifically an LS2 style dampener to suit a twin row timing chain setup. Sorry that I didn't film more of the reassembly process, guys. I was busy doing the heads while Rex was reassembling most of this bottom end. If you are interested to see how we actually do shim these pumps to ensure they are centered about the crank and installed correctly, I will link a video up here in the corner for you to watch. You can pretty much go back and watch any LS we've ever built on this channel and you'll see the process of us shimming the pump. It is something we always rag on about like a broken record. So here we are just testing the preload to see what sort of push rods we're going to need. Obviously with this new cam, we don't know what the base circle of the old cam was like compared to this new one. We are running the same lifters, but we have taken 60 thou off the heads, so chances are going to be new push rods at a different length. Sure enough, this thing needs 735s. We have some of these in stock, so we'll chuck some 735 push rods in this thing. It'll be happy days. Alright guys, so you can see what this valve plate looks like with these button head bolts and with that machine down a little bit just for clearance. We did a test fit here with the manifold to check clearance to the bolts. Not only that, but also to check the port alignment with these heads with 60 thou taken off. We had to make sure that, you know, this manifold wasn't going to be sitting right on the edge of the rubber seal on one of the ports or anything. Manifold fits fine, really good, so happy days, engine's ready to go back in now. We had to put a new oil pressure sensor in. That was something that has been a problem with this car for quite a while, and removing this engine from the car, we actually found that the coolant temperature plug on the loom was rooted, so we have to replace that as well. A few things to fix on the way, and then the customer actually has some new heater lines to go back into the car. It's pretty common for people to put VL heater lines in these VEs, which eliminates the heater lines that go up over the top of the engine. Just cleans up the engine bay a little bit, makes it look a bit nicer, so we'll put them on in the process. Righto guys, so we're on the dyno, we're ready to go for Monday. Rex has just drained all of the E85 out of it and we filled it up with 98, so we'll start again on the 98 and progress through our flex fuel tune. So this thing is cranky as, it's idling at about 10 more kPa than the old cam was, so still very, very grumpy, sounds very angry, and really excited to see what sort of power this makes. So. Alright, so there you go guys, on 98 tune we ended up at around 430 wheel horsepower, which is pretty good considering the last time I was here we only made 438 wheel horsepower on the E85 with the converter locked up. So considering the big converter in this thing through the auto, that 430 is not bad. Personally I did expect to see a little bit more, but we will see how we go on the E85. Drain the 98 out, let's go. Alright guys and girls, that's pretty much this thing sorted. We've pulled the plugs, checked our timing marks. That is pretty much all this thing wants to do. So we don't have any runs with the converter not locked up last time from E85, but as you can see, last time with the converter locked up, we've got a 438. We're not comfortable with dynoing these things with the converters locked up anymore. The lockup clutches in the converters, they're really only designed to take out that last 5% of slip at cruise RPM just to help with you know, fuel efficiency and that sort of thing. They're not designed to be taking the full load of an engine at full noise. So it's a little bit unsafe to run them locked up. That's why we're not doing it this time around. So funnily enough, actually, when the car first came here and we first ran it up on the dyno, whoever had tuned it previously actually had the converter lock up on all the time in those gears. So when we actually ran it up, the ECU was tuner locked. We couldn't even see or change anything. And that run on the E85 with the converter locked up, the way it arrived to us was 418 horsepower at the wheels. And yeah, the converter lockup was on, which was a bit of a worry, a bit unsafe, not too cool, but obviously that's what someone has done to try and achieve a number for a combo that really wasn't just doing it. So anyway, overall, we have fixed this the best that we can.
You can see the 406 run we've got up there on the screen. That is with the converter unlocked on 98 last time. This time on 98 with the converter unlocked, we've managed a 436. So we've essentially making the same power now with the converter unlocked on 98 as it was making before with the converter locked up on E85. So quite a significant improvement. So that 457 is as much as it wants to do. Looking at the logs, we are getting around a 300 RPM slip during peak power in that run, which is about 5%, which makes sense. That's about what it's designed and tuned to be at. So with the converter locked up, you'd expect to see about another 5%. So if this was a manual or if we had the converter locked up, you would expect to see around that 480, which you know, for a stock bottom end 6 litre, that's pretty respectable. You know, with this big converter through the auto, just about 460, almost 460 at the wheels. Pretty happy with that. It is essentially all that we can do with this combo with what we've been given as far as trying to sort it out and fix it as best we can. I would be quite interested to see how these heads would compare to standard heads just as far as flow. You know, I've not seen any results from a flow bench for these particular ports, but I do have to wonder if the port cross-sectional area being too big is maybe having a negative effect on this thing being only six litres, not you know, a really high capacity engine or a stroker that could really use all that port. So not only the port, but I reckon if you were going to do something like this stock bottom end E85 and you really wanted to make use of that compression on E85, I definitely wouldn't get the chambers CNC'd. The advantages of having a nice smooth CNC chamber do not outweigh the disadvantages of losing that compression in this sort of combo. So that's definitely something that I'll be looking at if you're looking at building a similar combo like this. So that's it for this combo. We'll do a little bit of street driving, get this box tune sorted out with the new power and the new cam, and this thing can go back to its owner. And that's going to be it until such a time he wants to maybe stroke it or something like that. So that's the big VE with the onsong treatment. Thank you for watching as always, guys. Hope you've enjoyed this one. A little bit of a different format for this video. Let me know what you think of it. Filming in this format really sort of disrupts the workflow less in the workshop, so it sort of works out a little bit better all round. Hopefully it's also a little bit better for the viewers. Just let me know. Thanks for watching. Smash like, smash subscribe. We'll see you on the next one. Peace out. See you. Bye.